Good morning, kids. We are going to discuss the capacitor one shot. In 1 hour, I'm going to revise all the concepts that are involved in the capacitor. For JEE means, we'll get 1 or 2 questions. और आप जब एडवांस को देखेंगे तो 5-6 क्वेश्चंस इस चैप्टर से इंटरलिंक हुए रहते हैं कैपेसिटर के क्वेश्चन रहते हैं और बाकी 5-6 एक नहीं लाइक एलसी ऑपरेशन आरसी सर्क्यूट एसी करंट then capacitors, then current density. It will be interlinked or photovoltaic effect. In छः पांच chapter से link होता है capacitor chapter. So this is one of the important chapter and also very simple. You are going to learn lot of basics which will help you to learn other chapters like a current density. So please do. It's a compulsory chapter where you are not going to skip. You have to learn and solve the PYQ. So we'll start like this. So what is a capacitor? What is a like a what are all like a in one shot? How we have to summarize this one for exam? Another 1 hour, 1 day, 2 days exam is it? So how you have to plan? First, a basic idea what is a capacitor, then parallel plate capacitor, capacitance of spherical capacitor, then energy in capacitor, capacitors in series parallel, charge sharing concepts, capacitors, circuits, loop equation, junction law, types of capacitors, spherical, cylindrical, capacitor between two wires, between two spheres, capacitors with the dielectric, force on dielectric slab kept in capacitor, force of attraction between plates with the dielectric and without dielectric, dielectric breakdown. ये जो सभी टॉपिक्स हैं तो इसके बारे में आपको कॉन्सेप्ट क्लैरिटी पहले चाहिए. व्हाट इज द नेसेसिटी ऑफ द एग्जामिनेशन इज कॉन्सेप्ट क्लैरिटी पहले. आपको ये सभी कॉन्सेप्ट लेके देख के फिर थोड़ा याद कर लेके समझ लेके देन यू हैव टू रिवाइज फॉर्मूला. बाद में आप जब पीवाईक्यू करेंगे देन यू कैन सी द बेनिफिट. फर्स्ट रिक्वायरमेंट इज कॉन्सेप्ट क्लैरिटी, सेकेंड फॉर्मूलाज, then solving PYQ. So these are the requirement. So just तुम like a one shot देके सीधा मैं सर like I am solving PYQ. Okay fine. जो भी like जो मैं यहाँ पे 1 hour में जो क्विक रिविजन कर रहा हूँ इसको आप समझ लेना चाहिए. देन जो जो फॉर्मूलास है उसको याद कर लो. then parallelly solve PYQ. Then you will be in a very good better position. जो आप ए वन शॉट देखते हो इसका आपका फायदा आप एग्जाम में और से लेकर जब एग्जाम लिखते हो देन यू कैन सी द बेनिफिट. तो दिस आर ऑल द रिक्वायरमेंट्स. हम जो वन शॉट यहाँ पे मैं डिस्कस कर रहा हूँ ऑल दीज थिंग्स आर देयर. Okay, we'll start with the first one. What is a capacitor? So capacitor is a device. Capacitor is a device which will store charges. Charges or used to store electrostatic energy. Okay, fine. So this is one basic idea. यहाँ पे बहुत सारे कैपेसिटर्स है. हर एक कैपेसिटर व्हाट इज द पर्पस ऑफ देम? हम इसको चार्ज स्टोर करने के लिए और इलेक्ट्रोस्टैटिक एनर्जी स्टोर करने के लिए यूज करते हैं. एंड ऑलवेज सी दैट कैपेसिटर विल कंपेयर विद द बकेट. यहाँ पे हम सभी को पता होगा बकेट. एंड यहाँ पे हम कैपेसिटर इस तरह का पैरेलल प्लेट कैपेसिटर पहले हम डिस्कस करेंगे ना. दिस वन. तो व्हाट इज द कैपेसिटर? इसका कैपेसिटेंस रहता है. यहाँ पे हाउ मच ऑफ वाटर यू कैन स्टोर, कैपेसिटी ऑफ बकेट. देन यहाँ पे इसका पोटेंशियल डिफरेंस, यहाँ पे हाइट, यहाँ पे जब आप चार्ज फिलअप करोगे देन सिमिलरली हियर सम चार्जेस विल बी फिल्ड अप, Q एंड माइनस Q. यहाँ पे एनर्जी, इलेक्ट्रोस्टैटिक फील्ड एनर्जी. जैसे bucket, it will store water. Similarly, capacitor will store the charges, plus Q minus Q. Fine. यहाँ पे हम पोटेंशियल बात कर रहे, दिस विल बिकम हाइट. देन यहाँ पे V इक्वल टू क्यू बाई सी हम करते, लाइक कैपेसिटेंस, चार्ज एंड पोटेंशियल. चार्ज मीन्स वाटर, तो यहाँ पे हम चार्ज लिखते हैं. यहाँ पे हम चार्ज इन कैपेसिटर, इसको हम क्या बोलते हैं, वाटर इन बकेट. कितना पोटेंशियल है अक्रॉस कैपेसिटर, कितना हाइट है वाटर बकेट में, वाटर का कितना हाइट है. सिमिलरली व्हाट इज द पोटेंशियल ऑफ कैपेसिटर, इसका कैपेसिटेंस कितना है. सिमिलरली बकेट का कैपेसिटी कितना है. तो जिस तरह बकेट स्टोर वाटर, उसी तरह कैपेसिटर विल स्टोर चार्जेस. This is one basic thing. So how that potential, charge and capacitance are related, there is a formula. So what is the potential symbol V, charge का symbol Q, and capacitance का symbol C. How all ये तीनों किस तरह relatable है, तो we can write V equal to Q by C, and potential is inversely proportional to capacitance, and potential is directly proportional to capacitance. This is one basic idea of the capacitor. Next, capacitance of a parallel plate capacitor. This is an ideal one. इसका हम capacity find out करेंगे. This is a parallel plate capacitor. इसमें क्या क्या रहता है कैपेसिटर. I'll give charge plus Q minus Q. There will be an electric field will be set up inside it. इसका एरिया ऑफ क्रॉस सेक्शन A एंड दिस इज D. अगर आप फिजिकली देखेंगे तो इट विल बी ऑफ लाइक दिस. दो पैरेलल प्लेट, इस तरह कनेक्शन हो रहे थे. सो यहाँ पे हम चार्ज दे रहे प्लस Q माइनस Q. इसका सेपरेशन D. एरिया ऑफ क्रॉस सेक्शन ऑफ प्लेट्स इज ए. ये पैरेलल प्लेट का कैपेसिटेंस हम फाइंड आउट करेंगे. इलेक्ट्रिक फील्ड इज E. दिस is plate 1, plate 2. So what is the net electric field will be due to the positive plate and negative plate. Due to positive plates, sum of electric field due to negative plate. This should be equal to sigma by 2 epsilon naught, sigma by 2 epsilon naught, sigma by epsilon naught. Sigma बोले तो यहाँ पे charge density, charge by area. यहाँ पे हम पोटेंशियल डिफाइन करेंगे. व्हाट इज द पोटेंशियल डिफरेंस, E into D. In uniform electric field, what is the potential difference? Potential difference should be equal to electric field into distance. So इसका Q by कैपेसिटेंस का डेफिनेशन क्या है, C इक्वल टू Q by V, या पोटेंशियल QD by A epsilon naught. जब हम सॉल्व करेंगे, this will be epsilon naught A by D. So what is the capacitance of parallel plate capacitor? Epsilon naught A by D. This is the capacitance of parallel plate capacitor. Then what is the energy stored in the capacitor? Q square by 2C. Or since Q equal to C into V, we can also write CV square by 2 or QV by 2. This is the capacitance of a capacitor formula, and this is the energy stored in capacitor. यहाँ पे energy is गैप में रहता है. So the energy will be stored by the capacitor in this particular gap, here, in the form of electrostatic field. So what it will store? It will store electrostatic field energy between its plates, or it will store charges. There's the expression for capacitance of parallel plate capacitor. There's a one formula which you should remember, and there's the energy of the capacitor. Next, we'll take the another parallel plate spherical capacitor. So spherical capacitor में there's a yeah, there's a iron sphere. I'll give charges. जो हम charge देते हैं ना, so this will go and deposit it on the surface, and it will produce electric field in all directions. It will produce electric field in all directions. Okay, fine. Now, इसका capacitance find out करेंगे. Then what is the basic definition? What is the potential at point P? Potential at point P on the surface of conductor is given by spherical KQ by R. K का value कितना है? 4 pi F naught R. Then what is the definition for capacitance? C equal to Q by Vp. Q by potential is given by 4 pi epsilon naught R. So इसका कितना हुआ? 4 pi epsilon naught R. So this is a capacitance of spherical conductor. This will be our formula. आपको रिमेंबर करना पड़ता है, very important. तो the capacitance of spherical conductor depends on what? Depends on its radius. इसका radius कितना है यहाँ पे? R. So it depends on this radius R. Then sir, a hollow or solid, जो भी रहने दो, the capacitance of spherical, whether it's a hollow or solid, it depends on its radius 4 pi epsilon naught R. Then what is energy stored in this? That's the same formula. Energy stored equal to Q square by 2C. C का वैल्यू सब्स्टिट्यूट करो, 4 pi epsilon naught R Q square by 8 pi epsilon naught R, or this will become K Q square by 2R. This is a energy of a spherical capacitor. ए बी फॉर्मूला आपको याद रखना पड़ेगा, very important. Capacitance कितना? 4 pi epsilon naught R. KQ square by 2R is what? Energy stored by the spherical capacitor. We'll take the next one. Series and parallel. Capacitors in series and parallel. When capacitors are series parallel. What do you mean by पहले series हम discuss करेंगे. What do you mean by capacitor series? यहाँ पे. So this idea is very important. इस तरह का कनेक्शन इसको हम सीरीज बोलते हैं, लेकिन इसका कैपेसिटेंस C1, C2, चार्ज Q1. नो, यहाँ से हम स्टार्ट करेंगे. फ्रॉम हियर द चार्ज विल एंटर द बैटरी. व्हाट इज दिस? दिस इज सेल which will supply charges. What is the cell? Supplies energy. The charge will go and deposit here, plus Q minus Q. The charge will flow like this, and this will go and deposit plus Q minus Q. From here plus Q, and from here plus Q will come out like this. And what is the basic idea? How much of charge will leave positive terminal? That much of charge should enter the negative terminal. And there's a one conservation of charge should be obeyed, very, very important. So then what is the basic formula? Capacitance, when the capacitance are in series, same charge will remain same and potential difference will be different. तो हम करेंगे यहाँ पे V1, इसका potential difference V2. So in series capacitors, what is the condition? Q will be same, V will be different for different capacitors. Q will be same for all capacitors and potentials will be different for different capacitors. Then effective capacitance, the effective capacitance is given by C equal to 1 by C equal to 1 by C1, 1 by C2, or C is equal to C1, C2 by C1 plus C2. Then the potential formulas, V1 equal to E C2 by C1 plus C2. V2 equal to E C1 by C1 plus C2. These are the potential divider formulas. And it will obey and what all we applied voltage, that will get dropped across sum of these two. Okay, fine. What all the work done by this cell, half of it will go in this half of it will go in both the capacitor, the remaining will be heat generated. Okay, fine. So यहाँ पे, so this is about the series का. So what about the what is this? These are called as potential divider formulas. Potential divider formula. Okay, I agree this. Then, what about the heat generated? Heat generated इस तरह आप करेंगे. Initial energy in the circuit, work done by cell is equal to final energy plus heat generated. Initial energy in circuit 0, work done by cell कितना QE. Final energy in capacitors Q square 2C1, Q square 2C2 plus heat generated. Now what is the Q? Q to effective C into E. So यहाँ पे what is C again? C1 C2 by C1 plus C2 E square Q square 2C1 H. What is H? H is heat generated. इस तरह हम सीरीज में heat generated भी find out कर सकते हैं. Okay, this is about the series. तो next parallel ले लेंगे. पैरेलल में अगर दो कैपेसिटर्स है, दो या तीन, इफ यू कनेक्ट देम लाइक दिस, ये वाला तो सेल हो चुका है, और दिस इज द सेल. नो, दिस इज द ई. इसका कैपेसिटेंस C1 C2. पोटेंशियल डिफरेंस विल बी सेम, एंड ये पोटेंशियल डिफरेंस कितना होगा? दैट ऑफ अप्लाइड अक्रॉस द सेल. चार्ज जो है इट विल बी डिफरेंट. यहाँ पे चार्ज Q2 माइनस Q2, Q1 माइनस Q1. सो यहाँ जो चार्ज फ्लो हो रहा है Q1 Q2, Q2 Q1, same Q. So the battery, the charge from here will go. It'll break up Q1, Q2 based on the capacitance. Then here plus Q2 will become minus Q2. From here plus Q2 will come like this. Here Q1 minus Q1. From here plus Q1, Q2 will get added up, will get Q. How much of charge will leave positive terminal? That much should enter negative terminal. So like this, and they are at same potential. If you see potential of this plate same, this plate are same. So let me indicate here. Potential, you call this is AB, xy. Potential of A equal to x, potential of B equal to y. So therefore VAB equal to VXY equal to E. So in parallel, what will be common? Potential will be same. Potential will be same. What about the charge? Charge will be different. Charge will be different for different capacitor. Then what is the effective capacitance? Effective capacitance given by C1 plus C2. Then charge divider formula Q1 equal to QC2 by C1 plus C2. Q1 equal to QC1 by Q2 equal to QC1 by C1 C2. There's a effective capacitance. This one is a charge divider formula. When capacitors are parallel, effective capacitance is given by this particular thing. You have to remember. And this is the charge divider formula. What about the heat generated? यहाँ पे heat generated, again same formula. Heat generated, work done by cell is equal to final energy plus heat generated. Initially there was no energy in circuit, work done by cell, Q into E. Final energy, Q1 square by 2C1, Q2 square by 2C2 plus H. What is H here? H is heat generated. What is the Q? Q यहाँ पे हम इस तरह लिखेंगे C into E. So what is the C? C equal to C1 plus C2. So C1 plus C2 E square Q1 square 2C1 Q2 square 2C2 plus H. Solve for H. So in parallel circuit, so like this we can calculate the heat generated in the circuit. कहाँ पे लगे heat generated where not in capacitor. In this connecting wires the heat will be generated. ये जो रेड कलर हम वायर दिखा रहे हैं ना, यहाँ पे heat generate होता. So heat generated in circuit. This was the H. इसको तुम वेरी इंपॉर्टेंट आपको याद रखना पड़ेगा. वेरी वेरी इंपॉर्टेंट फॉर जेईई मेंस. Next we have the charge sharing concepts and heat generated. There's one very important topic, plenty of times asked in JEE mains advance. यहाँ पे जो भी cases है मैं यहाँ पे neatly explain करता हूँ. This is a topic which everyone should understand. पहले यहाँ से शुरू करेंगे. Charged, this is the uncharged capacitor. If it is connected to charged capacitor, then what are the conditions? Charged capacitor connected to uncharged capacitor. This is the first case. C1, C2 इसमें charge है. Initial charge Q0 minus Q0. C2 is uncharged. So यहाँ पे हम A वाला तो charged capacitor है. It is connected to uncharged capacitor. So what will happen to the charges that we have to discuss? Final circuit, switches close करेंगे. Then the charge here Q1, A वाला minus Q1, this will be Q2 minus Q2. This is a charge capacitor. It will be connected to uncharged capacitor. Then this is at higher potential, then this lower potential charge will flow from higher to lower potential. So this charge Q0, a part of it will start flowing here. So finally when potential of this plate becomes equal to this, when these two are at same potential, no charge will flow here. That's one basic idea. So यहाँ पे हम, so finally they will have same potential. Then what is the condition? Charge is conserved, Q naught equal to Q1 plus Q2, charge of this plate. यहाँ पे चार्ज कितना था? Q naught. यहाँ पे 0. Charge of these two plates is conserved. Then initially what was the charge? Q naught, this will be 0. बाद में कितना है चार्ज? जब ये वायर दोनों कनेक्ट करेंगे तब इसका Q1 एंड इसका Q2 होगा. Then afterwards they are like a Q1 by C1 same potential, Q2 by C2. हमें Q1 Q2 फाइंड आउट करना है. सो Q नॉट इक्वल टू Q1 Q2 वैल्यू विल बी Q1 C2 बाय C1. Q1 equal to Q naught C1 by C1 plus C2. And what is the Q2? Q2 equal to Q naught C2 by C1 plus C2. These are the final charges. What is the heat generated? Initial energy, work done by cell, work done by external agent, final energy plus heat generated. Initially energy कितना है? Only in this energy there is a capacitor. So इसका हम क्या करेंगे? Q naught square by 2C1. यहाँ पे there is no battery, so work done by cell 0. यहाँ पे कौन भी external agent यहाँ पे काम नहीं कर रहा है. So what is the work done by external agent? That will be 0. So this will be 0, 0. Final energy. यहाँ पे charge कितना है? Q1. यहाँ पे charge Q2. So the final energy will be Q1 square 2C1, Q2 square 2C2 plus heat generated. So solve for H. This is one basic idea. Charge sharing means this capacitor will change charge with this one. यहाँ पे तुम लगे इतना घबराने के कुछ भी नहीं है यहाँ पे. So दो बकेट यहाँ पे हम कनेक्ट कर रहे हैं. इसमें पानी है, ये भरा हुआ है, इससे पानी है, ये वाला तो एम्प्टी है. तो बाद में क्या करेंगे हम? इसका जो वॉल है ओपन करेंगे. देन एवरी आपको दिस इज वेरी जनरल. इसके लिए कौन सा भी साइंटिफिक नॉलेज नहीं चाहिए. जब हम वॉल ओपन करते हैं सो व्हाट विल हैपन इज लाइक जो पानी है यहाँ पे है, सो इट विल स्टार्ट फ्लोइंग. नो, व्हाई इट विल फ्लो? बिकॉज दिस एट हायर पोटेंशियल देन दिस वन. यहाँ पे प्रेशर कितना? P naught plus rho GH. यहाँ पे प्रेशर 0, so water will flow from high to lower pressure. Similarly, here potential more, here 0 potential, so charge will flow from higher to lower potential. This is the concept. यहाँ पे कितना पानी था? 5 लीटर. वही 5 लीटर यहाँ पे रहेगा ना. So इसका कैपेसिटी अलग है, इसका C1 C2. So finally both will have same level. जैसे बकेट में पानी शेयर हो रहा है उसी तरह यहाँ पे चार्ज इज गेटिंग शेयर्ड. फ्रॉम व्हाट वी आर डूइंग, इस कैपेसिटर्स को हम किस तरह चार्ज कर सकते हैं? एक चार्ज कैपेसिटर के कनेक्ट कर लो, देन यू विल गेट चार्ज. दिस इज वन वेरी इंपॉर्टेंट थिंग. हीट जनरेटेड, एनर्जी गेन्ड, एनर्जी लॉस्ट बाय वन कैपेसिटर. नेक्स्ट कंडीशन, इफ चार्ज कैपेसिटर कनेक्टेड टू अनदर अनचार्ज कैपेसिटर. इसका चार्ज Q1 minus Q1 minus Q2 plus Q2. Then what will happen? Here also now charge sharing will occur. Second case, charged capacitors are connected. फाइनल चार्ज Q1, ये माइनस Q1. इसका चार्ज पता नहीं, I'll write it minus Q2 plus Q2 minus Q2. सर यहाँ पे हम why you are taking positive? I'll solve it. मुझे यहाँ पे नेगेटिव आया तो I'll change the polarity. अगर Q2 पॉजिटिव आया तो what I assumed is correct. If Q2 is negative, what I assumed is wrong. Fine. They'll have same potential. finally. Then charge of these two plates are conserved. कौन सा दो प्लेट ले लो, either these two plates or these two plates, charge will be conserved. Then I can applying conservation of charge principle, Q1 minus Q2, Q1 minus Q2 equal to Q1 plus Q2. Conservation of charge principle. Conservation of charge principle. Next, they are finally at same potential. Then what is the potential difference across this capacitor? Q1 by C1, and potentials must be equal. Q1 by C1 equal to Q2 by C2. So यहाँ पे substitute कर लो, then we'll get the charges. Then what about heat generated? Initial energy, work done by cell, work done by X-ray agent equal to final energy plus heat generated. Initial energy यहाँ पे Q1 square by 2 C1, Q2 square by 2 C2. यहाँ पे cell कौन सा भी नहीं है, no X-ray agent. Final energy Q1 square 2 C1, Q2 square 2 C2 plus heat generated. Heat will be generated in circuit. So if a charged capacitor connected to another uncharged capacitor with a reverse polarity, this is a method. You have to be alert with this. Conservation of charge principle. This is the conservation of energy principle. Conservation of total energy. Total energy is conserved यहाँ पे. Then we'll get a situation where one charge capacitor to multiple charge. रफ डायग्राम डाल देता हूँ मैं. इसका कैपेसिटेंस C1, चार्ज माइनस Q1, इसका चार्ज Q माइनस Q2, इसमें कौन सा भी चार्ज नहीं है. ये C2, दिस इज C3. So charge capacitor, uncharged capacitor, if they are connected. यहाँ पे मैं switches close कर देता हूँ. They are open. ये तीनों switch हम close करेंगे. Then what is the condition? We'll close the switch. Final charges पता नहीं Q1 minus Q1, Q2 minus Q2, Q3 minus Q3. Then charge ये दोनों प्लेट का चार्ज should be conserved. बाद में ये दोनों प्लेट का चार्ज है, that will be conserved, and these two plates will be conserved. Conservation of charge principle. यहाँ पे हम जंक्शंस को एक नाम दे देंगे, तो दे दे जंक्शन ए, जंक्शन बी, जंक्शन और स्विच. At A, what was the initial charge? Q1 minus Q2. Final charge Q1 plus Q2. At B में initial charge क्या है? Q2 and 0. Final charge minus Q2 plus Q3. Q2 plus 0. At C, minus Q1 plus 0, minus Q1 minus Q3. देन राइटिंग लूप इक्वेशन, यहाँ पे इस you start moving here, ऐसे ट्रैवर्स करेंगे. If you move from negative to positive plate, rise in drop. Positive negative plate, fall in drop. Positive negative plate, fall in drop. So इस तरह जाएंगे ना. Q1 by C1 minus Q2 by C2 minus Q3 by C3 equal to 0. Then heat generated, initial energy equal to final energy plus heat generated. यहाँ पे initial energy calculate करो, final energy calculate करो, then substitute here, then we'll get the heat generated. अगर बहुत सारे कैपेसिटर्स चार्ज शेयरिंग करें तो सो देयर इज वन बेसिक मेथड, चार्ज शुड बी कंजर्व्ड. Next one, capacitor circuit, loop equation, junction law. This is about all the circuits, are different methods are there. तो पहले हम loop equations के बारे में डिस्कस करेंगे यहाँ पे. तो यहाँ पे this is circuit, we have to calculate the charge कि कौन सा कैपेसिटर में कितना चार्ज है. So here what are the basic ideas here? Conservation of charge principle, very important. Charge of system is conserved. इसी के ऊपर ही ऑल प्रॉब्लम्स यहाँ पे हम डिस्कस करने वाले हैं. कंजर्वेशन ऑफ चार्ज प्रिंसिपल, कंजर्वेशन ऑफ चार्ज प्रिंसिपल, बेटर इसको COCP, कंजर्वेशन ऑफ चार्ज प्रिंसिपल. सो फर्स्ट यहाँ से पॉजिटिव चार्ज, it will flow like this. The positive charge will come and deposit here. Let me indicate those charges, plus Q minus Q. Then from here the charge will come, plus Q, it will deposit, plus Q minus Q. This is a charge flow. So यहाँ से हम स्टार्ट करेंगे. This battery will send positive charge plus Q, will deposit plus Q minus Q. यहाँ से plus Q आके इस बैटरी से गुजर के it will go and deposit here plus Q. Fine. Then this will induce minus Q. यहाँ से plus Q निकल के it will go and deposit on this particular plate and it will induce minus Q. यहाँ से plus Q निकल के it will pass through this battery, यहाँ पे डिपॉजिट हो जाता है. फाइन. सो दिस विल इंड्यूस चार्ज माइनस Q. यहाँ से प्लस Q निकल के इट विल एंटर नेगेटिव टर्मिनल. जितना चार्ज पॉजिटिव टर्मिनल से एंटर लगे एग्जिट होता है उतना ही चार्ज नेगेटिव टर्मिनल को इट शुड बी एंटर. तो नथिंग बट चार्ज शुड बी कंजर्व. हर एक का बैटरी देख लो तुम, यहाँ से कितना चार्ज पॉजिटिव टर्मिनल से निकल रहा है प्लस Q, कितना एंटर हो रहा है नेगेटिव टर्मिनल में प्लस Q. सो द चार्ज शुड बी कंजर्व्ड. दिस इज वन बेसिक आइडिया. देन इसके लूप इक्वेशन लिख देंगे. सो आई एम ट्रैवर्सिंग लाइक दिस. यहाँ पे अपने आप को इमेजिन कर लो, आप यहाँ से ऐसे गुजर रहे हैं. सो यू आर रनिंग क्लॉकवाइज एंटी क्लॉकवाइज. सो अगर आप पॉजिटिव नेगेटिव टू पॉजिटिव टर्मिनल मूव हो रहे सो देन राइज इन ड्रॉप. सो प्लस E1 अक्रॉस कैपेसिटर, फॉल इन ड्रॉप Q by C1. पॉजिटिव टू नेगेटिव टर्मिनल ऑफ बैटरी जा रहे हैं सो fall in drop minus C2 across battery plus Q2 minus Q. So therefore this will be minus QC2 minus QC3 plus E3 minus E4 minus Q by C4 equal to 0. A Q is unknown. Then heat generated, work done by cell, initial energy, work done by cell plus final energy plus heat generated. इसको हम लूप इक्वेशन बोलते हैं. दिस वन. नेक्स्ट सर्क्यूट ले लेंगे. विल टेक अनदर सर्क्यूट. दिस है E1, E2, C1, C2, C3। चार्ज डिस्ट्रीब्यूशन यहाँ पे हम सॉल्व करेंगे। तो यहाँ से प्लस क्यू विल कम, Q1 माइनस Q1 फ्रॉम हियर Q1, यहाँ से Q2 चार्ज विल कम एंड डिपॉजिट हियर, यहाँ से Q2 चार्ज, Q1 प्लस Q2 डिपॉजिट यहाँ पे होगा, माइनस Q1 प्लस Q2, Q2 जैसे Q1। देन कितना अननोन्स है, Q1 Q2 दो अननोन। सो यहाँ पे लूप इक्वेशन यहाँ पे लिख देंगे हम। सो प्लस C1, दिस अ पाथ यहाँ पे मैं ले रहा हूँ, ओके फाइन। इसका इक्वेशन लिख देंगे, प्लस C1 माइनस Q1 बाई C1 प्लस Q2 बाई C2 माइनस C2 इक्वल टू 0। इसका इसका वन मोर इक्वेशन चाहिए ना, सो विल राइट वन मोर इक्वेशन, ए वाला लूप ले लेंगे। सो दिस इक्वेशन विल बी E1 माइनस Q1 C1 इक्वल टू 0। कितना अननोन्स है यहाँ पे, Q1 Q2, दो इक्वेशन दो अननोन। चार्ज डिस्ट्रीब्यूशन सर लिखे, जो जो हम चार्ज डिस्ट्रीब्यूट कर रहे हैं, सो इट शुड सेटिस्फाई द कंजर्वेशन ऑफ चार्ज प्रिंसिपल। यहाँ पे पॉजिटिव टर्म से कितना चार्ज पास हो रहा है Q1, और उतना ही चार्ज रिटर्न आना चाहिए। सो दिस वन बेसिक आइडिया, चार्ज ऑफ ए सेल शुड बी कंजर्व्ड। सिमिलरली यहाँ से कितना चार्ज बाहर जा रहा है Q2, उतना ही चार्ज नेगेटिव टर्मिनल इट शुड एंटर, then charge should be conserved. So what is the basic idea? Charge of a cell must be conserved. These ideas, इसके बारे में आपको सोचना पड़ेगा. This is very important. Similarly, charge of a capacitor is also conserved. इसका चार्ज कितना था, 0। अब भी कितना है, 0। The net charge of capacitor should be 0. उस तरह आप चार्ज डिस्ट्रीब्यूट करना पड़ता है। ओके, वन मोर सर्क्यूट ले लेंगे। सो सम कुछ सर्क्यूट्स आपको इस तरह भी होंगे। E1, E2, C1, C2। हमें यहाँ पे चार्ज फाइंड आउट करना है। इसका चार्ज कितना है हमें पता नहीं, सो विल राइट Q1 माइनस Q1, ये वाला Q2 माइनस Q2। Q1 Q2 दो नॉन थिंग्स है, वी हैव टू फाइंड आउट। सो यहाँ पे एक लूप लिखवे, दिस अ पाथ ट्रैवल द लूप लाइक दिस। सो हाउ मच विल गेट प्लस C1 माइनस Q1 बाई C1 इक्वल टू 0। और एक ये लूप ट्रेस आउट कर लो, this should be equal to plus C1 plus Q2 by C2 minus C2 equal 0। this is a path, हम ये पाथ में जा रहे हैं। दोनों नोन से या फाइंड आउट कर लो। देन अगला सर्क्यूट हमें इस तरह भी एक सर्क्यूट्स विल कम अक्रॉस। C1, C2, C3, इसका पोटेंशियल V3, इसका पोटेंशियल V2, इसका पोटेंशियल V1। आई वॉन्ट टू फाइंड आउट द चार्जेस एंड इसका पोटेंशियल कितना है, पोटेंशियल V0। यहाँ पे कंजर्वेशन ऑफ चार्ज प्रिंसिपल, चार्ज Q1 माइनस Q1 will go and deposit Q2 minus Q2, Q3 minus Q3। charge of isolated junction should be conserved, 0.0। this is very important। एक काम करेंगे, there's a initial, यहाँ पे कितना चार्ज है, यहाँ पे 0 चार्ज 0 चार्ज 0 0 0। so charge of this junction should be conserved। this is the basic idea। दिस आइसोलेटेड जंक्शन. So इसका चार्ज शुड बी कंजर्व्ड. So इनिशियली यहाँ पे चार्ज कितना है एट ओ व्हाट इज द चार्ज 0 + 0 + 0. फाइनली कितना चार्ज है यहाँ पे Q3 Q2 एंड माइनस Q1. वही जंक्शन को आई इंडिकेट हियर, इंडिकेट करेंगे. सो नाउ यहाँ पे -Q1 + Q2 + Q3. तो चार्ज एट आइसो जंक्शन शुड बी कंजर्व्ड. बाद में कितना, यहाँ पे 3 अननोन है, सो इक्वेशंस लिखेंगे. सो लूप इक्वेशन. सो मैं यहाँ पे स्टार्ट कर रहा हूँ +V1. जहाँ पे आप स्टार्ट करते हो वो पॉजिटिव, देन -Q1/C1 -Q3/C3 -V3 = 0. This one +V1 -Q1/C1 -Q3/C3 -V3 = 0. ए वाला लूप इक्वेशन लिख देंगे इस तरफ. +V1 -Q1C1 -Q2C2 -V2 = 0. +V1 -Q1C1 -Q2C2 -V2 0. ओके सर, लाइक आप लाइक इस तरह लूप इक्वेशन क्यों नहीं लिखते हैं? वी कैन राइट इट V2 + Q2C2 -Q3C3 -V3 = 0. जहाँ पे आप स्टार्ट करते दैट इज अ पॉजिटिव. अगर आप कैपेसिटर पॉजिटिव टू नेगेटिव, नेगेटिव टू पॉजिटिव टर्मिनल जा रहे हैं, सो राइज इन ड्रॉप. पॉजिटिव टू नेगेटिव टर्मिनल जा रहे हैं, सो दैट विल बी फॉल इन ड्रॉप. जहाँ पे एंड होते -V3 = 0. दिस विल बिकम वन क्लोज लूप. सिमिलरली अक्रॉस द बैटरी, अगर आप पॉजिटिव टू नेगेटिव टू पॉजिटिव टर्मिनल जा रहे हैं, सो राइज इन ड्रॉप. पॉजिटिव टू नेगेटिव टर्मिनल जा रहे हैं आप, like this. If you are moving, there's a part rise in drop, then rise in drop. यहाँ पे fall in EMF -C2. आप जब पॉजिटिव टू नेगेटिव प्लेट जा रहे हो तो -C2, नेगेटिव टू पॉजिटिव प्लेट जा रहे हो तो राइज इन EMF +C1 अक्रॉस द कैपेसिटर. अगर आप पॉजिटिव टू नेगेटिव, नेगेटिव टू पॉजिटिव प्लेट जा रहे हैं, सो विल बी राइज इन ड्रॉप. दिस अ सिंपल आइडिया सर. बहुत सारे सर्क्यूट्स अगर आप प्रैक्टिस करोगे तो लिटिल बिट इट बी इजी फॉर यू. दूसरा सर्क्यूट्स ले लेंगे. वी हैव टू कैलकुलेट द कैपेसिटेंस. इसका कितना है? 2 फैरेड, 4 फैरेड, 3 फैरेड, 6 फैरेड. इफेक्टिव कैपेसिटेंस कैलकुलेट करना है. तो ये जो दीज आर द वायर्स, ये जो मैं दिखा रहा हूँ, ये वायर है. तो व्हाट टू डू विथ वायर? आप जब भी आप एक वायर देखेंगे, सो यू हैव टू मेक दैट एज इक्विपोटेंशियल. इसका एक विल इंडिकेट द नेम्स 1 2 3 4. So 1 and 2 का सेम पोटेंशियल है. सो x विल स्टार्ट फ्रॉम x. यहाँ पे x है 1, 2, 3, 4, y. 3 and 4 connected by wire, and 4 is connected to y, no? Between x and 1, 2 farad capacitor. So इसका 2 farad. बाद में 1 and 3 का 4 farad है यहाँ पे. Three and 2 का, between 3 and 2, 3 farad is there. Between 2 and 4, 6 farad. Now we have to calculate between the तीनों capacitors, they are in parallel. Then effective is in series. So what is effective capacitance will be 6xy 1 by 6xy equal to 1 by 2. इसका effective capacitance कितना होगा? 6 plus 4 10 plus 13. Solve for 6xy. So these are called as a equipotential methods. आपको Wheatstone network पता ही होगा. So that also let me revise. C1, C2, C3, C4, C5. Point AB. This is XY. When Vx equal to Vy, then there is no charge in the capacitor. So this capacitor, there is no charge. They are at same potential. So we can remove it. अगर आप जब इसको remove करेंगे, then this will become simple. So they are ये दोनों series में. Okay, fine. And like these things are in parallel. These things are in series. So how these two are in series, these two are in series, effective is in parallel. So then when this happens, then we can write C1 by C2 equal to C3 by C4. When this condition is satisfied, then Vx equal to Vy. If this condition is satisfied, ratio of these two arms, C1 by C2 equals C3 by C4, then Vx equal to Vy. Then you can remove this capacitor. Then these two will appear series. The effect will be in parallel. So then we can write it in this way. CAB equal to C12 plus C34. What is 1 by C12? Equal to 1 by C1 plus 1 by C2. Similarly, okay, fine. So इसका कैपेसिटर इस तरह का सर्क्यूट से छोटे छोटे लगे टू रियली वर्कआउट है 10-15 प्रॉब्लम यहाँ पे हम लगे यू ट्राई टू वर्कआउट थिंक ऑन देम डेफिनेटली कैन मैनेज. कुछ दूसरा सर्क्यूट दिखा देता हूँ. नेक्स्ट वी हैव द यहाँ पे 2 फैरेड कैपेसिटर है 1 फैरेड इसका इनिशियल वोल्टेज कितना है 1 वोल्ट. यहाँ पे 3 फैरेड इसका पोटेंशियल ड्रॉप 2 वोल्ट है. दोनों बैटरी को हम यहाँ कनेक्ट कर चुके हैं. देन व्हाट इज द मेथड लाइक? आर दे सीरीज? नो, दे आर नॉट इन सीरीज. अगर कैपेसिटर्स में इनिशियल चार्ज रहे तो देन दे आर नॉट इन सीरीज. दिस इज वेरी इंपॉर्टेंट. They are not, though they are in appear to be physically series, they are not in series. They are not in series. Then how to solve the problem? इस सर्क्यूट को यहाँ पे हम फाइनल चार्ज यहाँ पे Q माइनस Q. इसका इनिशियल चार्ज कितना था? लेके Q2 ले लेंगे. Q2 माइनस Q2. इसका चार्ज Q3 माइनस Q3. यहाँ से जो चार्ज will assume यहाँ से प्लस Q generate होके it will get deposited plus Q minus Q. Then from here plus will come. वो plus Q यहाँ पे deposit होता है ना. So initially what was the charge of this? It was Q2. So यहाँ पे हम एक काम करेंगे. So this will become what was the Q2? Q2 का value calculate करेंगे. Q2 equal to 1 into 1 coulomb. Similarly Q3 का value capacitance 3 into 2 6 coulomb. So this will become Q2 plus Q. This will become minus of Q2 plus Q. The charge Q will come here and it will flow out. Q, Q. So यहाँ पे चार्ज कितना था? So this will be minus plus Q3. So Q3 plus Q minus of Q3 plus Q. Q charge, Q charge, Q charge. Like this it will flow. Q is unknown thing. इसको हम find out करेंगे. So यहाँ पे there's a one loop equation, we have to write it. सर अगर Q नेगेटिव रहे तो then what we assumed in opposite direction it will flow. The loop equation यहाँ पे मैं start कर रहा हूँ. I'm moving from negative to positive plate across the cell. So rise in EMF plus 10 minus Q by 2 minus Q2 plus Q by 1 minus 4 minus Q3 plus Q by 3 equal to 0. 10 Q का value we don't know. Q2 is 1 minus Q minus 4. Q3 value is 6 by 3 is what? 2 minus Q by 3. So 10 minus 1 minus 4, 10 minus 7, 3 equal to Q2 by 2 plus Q plus Q by 3. 5Q by 6 plus by 6. This will be 11Q by 6. So Q equal to 18 by 11 coulombs. Then what about heat generated? Initial energy plus final energy. Initial energy, work done by cell, charges living here. So how much it is equal to? Q by 10. It does positive work. And this cell does negative work because positive charge entering the positive terminal. So this will become minus Q into 4 equal to final energy plus heat generated. What is initial energy? You have to substitute this value. Initial का अलग सा separate लिख देंगे. Q2 square by 2 into 1, Q3 square by 2 into 3. What is the final energy? Q square by 2 into 2, Q2 plus Q whole square by 2 into 1, Q3 plus Q whole square by 2 into 3. This is a charge sharing. These are the basic ideas. अगर आप initial charge रहे तो they are not in series. अगर यहाँ पे charge नहीं है then these capacitors are in series. Because of initial charge they are not in series. So series parallel little bit careful. अगर initial charge रहे तो you have to be little bit alert. यहाँ पे find the heat generated after closing switch rate. So this is a 10 volt battery. This is 2 farad, 4 farad, 3 farad capacitor. जब अब हम इस switch को close करेंगे, what is the heat generated? Before closing switch we'll calculate how they are like a series parallel. यहाँ पे charge कितना होगा? Q1 minus Q1, Q1 minus Q1, and this charge will be Q2 minus Q2. So we'll calculate charge. Q1 10 minus Q1 by 2 minus Q2 by 4 equal to 0. This will become 20 by Q1 plus Q2 by 2. Sorry, Q1. 3Q1 by 2 और Q1 equal to 40 by 3 coulomb. Q2 का value कितना है? So directly disconnected across cell 3 into 10 30 coulomb. So now the switch is closed. जब हम ये switch close करेंगे we'll see what will happen. ये जो charge है this Q1 will flow from like this. So there won't be any, this capacitor will be shorted. Okay, fine. Then बाद में, so what is the charge? Earlier it was Q1, इसका जो charge है Q2. Then Q1 का value कितना है? So directly there it is directly connected across cell, no? अब आप देख लीजिए. So what is Q1 equal to? Q1 equal to 2 into 10, 20 coulomb. Q2 also directly connected across cell. 3 into 10, 30 coulomb. देन यहाँ पे हम ईट जनरेटेड कैलकुलेट करेंगे. हालिया कितना Q1 का वैल्यू, इसका Q1 का वैल्यू कितना है ए प्लेट में, यहाँ पे 40/3 कुलम. नाउ कितना चार्ज है 20 कुलम. 40/3 मीन्स 13.3. सो सम एडिशनल चार्ज विल एंटर हियर. यहाँ पे चार्ज एंटर होता है एंड दैट एडिशनल चार्ज शुड कम फ्रॉम हियर. हाउ टू कैलकुलेट द Q चार्ज. यहाँ पे चार्ज कितना था Q1. नाउ Q चार्ज हैज एंटर्ड, देन इज बिकम Q1 लाइक ए बकेट. थोड़ा इनिशियली पानी Q1 है, इसमें हम इस तरह कैपेसिटेंस का ले लो 2 फैरेड. Q1 चार्ज है, Q चार्ज एंटर होता है, तो इट विल बिकम कैपिटल Q1. वो बकेट कॉन्सेप्ट ऑफ बकेट अगर आप थोड़ा यूज करेंगे तो लिटिल बिट वेरी वेरी इजी फॉर यू. इनिशियली थोड़ा पानी है, अगर तुम और पानी डाले तो व्हाट विल हैपन टू द अमाउंट ऑफ पानी वहाँ पे, इट विल इंक्रीज. नो द सेम थिंग विद द कैपेसिटर. कौन सा था, एक प्लेट ले लो, पॉजिटिव प्लेट. अर्लियर चार्ज वाज 40/3. नाउ 20 कुलम इट हैज बिकम, मीन्स थोड़ा चार्ज तो एंटर होना चाहिए ना. So like this we'll find out the value of Q. So this should become equal to Q1 plus Q equal to Q1. So Q1 का value 40/3 plus Q1 will be 20. So Q का value will be 20 minus 40/3, 20/3 coulomb. Then initial energy UI plus UF, work done by cell. UI plus work done by cell equal to UF plus heat generated. UI कैलकुलेट कर लो. व्हाट इज द वर्क डन बाय सेल, यहाँ पे अलग से लिख देता हूँ, Q into 10. Positive charge will leave positive terminal, so therefore the cell will do positive work. Okay, these are some basic circuit problems. See, चुपके सुनने से यहाँ पे कुछ नहीं आता है, so you have to really put effort. समझ लेना चाहिए what is the method, what is the ideas involved. Then जाके तुम POIQ कर लो, then you'll get benefit. चुपके वन शॉट देखने से कुछ नहीं हो, नो 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 बेनिफिट. जब तक आप सोचोगे नहीं what is the method, what is the ideas involved, not possible. Next, spherical capacitors. So already हम पहले एक spherical capacitor का फॉर्मूला डिराइव कर चुके हैं. अगर मेरे पास this is the spherical capacitor, इसका रेडियस R, चार्ज Q चार्ज इज डिपॉजिटेड. दिस ए कंडक्टर, आयरन बॉल लिख देता हूँ. व्हाट इज द कैपेसिटेंस ऑफ इट, इसका कैपेसिटेंस तो C इक्वल टू 4πε0R, इसका कैपेसिटेंस है. देन कॉन्सेंट्रिक स्पेरिकल शेल्स, 2 शेल्स रहे तो, सो देन व्हाट इज द मेथड. इनर शेल का रेडियस A, दिस इज बी, शेल ए, शेल बी, यहाँ पे हम चार्ज दे रहे हैं. So we have to calculate the capacitance across terminals X and Y. पोटेंशियल डिफरेंस कैलकुलेट करेंगे. सो वी आर नथिंग बट यहाँ पे हम बैटरी कनेक्ट कर रहे हैं. दिस विल गो इन डिपॉजिट प्लस क्यू माइनस क्यू एंड प्लस क्यू यहाँ से पास होता है. सो दिस वन बेसिक आइडिया. देन पोटेंशियल डिफरेंस कैलकुलेट करेंगे. पोटेंशियल ऑफ एक्स और शेल ए, दिस शुड बी इक्वल टू के क्यू बाई ए minus kq by b. Potential of shell b, kq by b minus kq by b. So vxy equal to kq by a minus kq by b. Then now we define the capacitance q by vxy, q by kq by a minus kq by b. This will become 4 pi epsilon naught ab by b minus a. यहाँ पे 3 कैपेसिटर्स रहते हैं. सो दिस द बेसिक आइडिया. सर्क्यूट डायग्राम अगर मैं ड्रॉ कर रहा हूँ, सो इट विल बी ऑफ लाइक दिस. ये स्पेरिकल कैपेसिटर्स का हुआ. दिस इज एक्स, देन आप बाद में देख लो y, फ्रॉम y ऑल्सो देर बी वन कैपेसिटेंस एंड दैट विल बी टू इंफिनिटी. सर ये थोड़ा समझ में नहीं आ रहा. फ्रॉम y और ड्राइंग, फ्रॉम दिस सरफेस टू इंफिनिटी देर बी कैपेसिटेंस. सिमिलरली यहाँ से सरफेस पॉइंट y से टिल इंफिनिटी देर बी वन कैपेसिटेंस. वो कैपेसिटेंस मैं यहाँ पे दिखा रहा हूँ. बट आप यहाँ पे हम capacitance between the shells पूछ रहे. So he's asking between x and y. Between x and y will be only cxy. So what will be your answer? Your answer will be cxy. So these formulas are very important. Complete spherical shells, आपको ये formula याद रखना पड़ेगा. If inner shell is earthed, we have to calculate potential difference between x and y. ओके फाइन. तो यहाँ पे हम एक सर्क्यूट ड्रॉ करेंगे बिटवीन एक्स एंड वाई. यहाँ पे हम सेलेक्ट एक सेल कनेक्ट कर रहे हैं. ओके, सो नो कैपेसिटेंस इस तरह हम कैपेसिटेंस एक्स एंड वाई, एक्स वाई, फ्रॉम वाई टू इंफिनिटी. इंफिनिटी मीन्स पोटेंशियल भी जीरो और इनर्शियल एक्स is also connected. और हम जो सेल हम कनेक्ट कर रहे हैं, so it is like this. Okay sir, like x and y, okay fine sir. Why this y and infinity? Between outer surface b and infinity there will be one capacitance. Okay, now like a cxy, so दोनों capacitance. Now if you redraw the circuit, how it will be? It will be like this. Infinity y, x, y, So Cy infinity Cxy. So what is effective capacitance? Effective capacitance Cxy CAB equal to Cxy plus Cy infinity. Cx का value 4 pi epsilon naught AB by B minus A. 4 pi epsilon naught B. Inner shell, if outer shell is earthed, the same diagram. यहाँ पे हम outer shell को अर्थ करेंगे. Then what is the what are the conditions? Now if you can check it here, outer shell is earthed, shell B is earthed, then what is the capacitance? Then between A and B we will redraw the circuit. पहले circuit redraw करेंगे. X and Y, X यहाँ पे Y is earthed, Y से फिर infinity तक, और infinity भी earthed है. This is X and Y. यहाँ पे हम select. So this capacitor will be shorted. So effective capacitance CAB will be only CXY. वो कितना होगा 4 pi epsilon naught AB by B minus A. This will be shorted. This capacitor will be shorted. Why shorted? Because both Y as well as infinity, they are earthed. So this will be shorted. Shorted means the capacitance will be how much it will be? It will be like a infinity. So therefore what will happen? We'll consider only the effective capacitance is only CXY. I will take now if 3 shells are there. I'll earth innermost shell A, B, A, B, C. I'll find out capacitance between X and Y. Capacitance between X and Y. पहले X will draw the circuit. Between A and B there will be one capacitance. B and C there will be one capacitance. C and infinity there will be one capacitance. And infinity इसका zero potential, it should be earthed. यहाँ पे हम कौन सा शेल यहाँ पे earthed है? Shell B is earthed. यहाँ पे एक सिंबल लगा देंगे. Between what points? X and Y. Y कहाँ पे है? यहाँ पे Y है. This is a method. Between X and Y हम यहाँ पे सेल को कनेक्ट कर देंगे. अगर आप सेल को यहाँ पे ले रहे बोले तो it will be like this. What is this? This is a jumper, means no connection. नो इसको रीड्रॉ कर लो. These two are at same potential, that make them common. So ये तीनों ये वाला ए बी बी सी infinity C, and this is voltage, and this is cell E. We'll write down the capacitance. So CAB कितना है? CAB का value CAB equal to 4 pi epsilon naught AB by B minus A. CBC 4 pi epsilon naught BC by C minus B. CC infinity will be 4 pi epsilon naught C. These two are parallel. ये दोनों पैरेलल है. इसका इफेक्टिव विल बी इन सीरीज. दैट वाज द कैपेसिटेंस सी एक्स वाई. सो सी एक्स का वैल्यू इस तरह फाइंड आउट करेंगे. 1 by सी एक्स वाई इज इक्वल टू 1 by सी ए बी प्लस सी बी सी प्लस सी सी इंफिनिटी. ओके फाइन. हर्टेशियस दिस इज मोर देन इनफ. कौन सा भी so, पहले कितना है? 1 2 3 एंड और इन्फिनिटी. यहाँ पे दिस इज वेरी इंपॉर्टेंट. इन्फिनिटी भी एक प्लेट. You should assume infinity also will become one of the plate of capacitor which will have zero potential. Between A and B one capacitor, B and C one capacitor, C and infinity one capacitor. Then कहाँ पे हम पूछ रहे हैं? Like we are asking about the between X and Y. So X and Y वहाँ पे सेल कनेक्ट कर दो. जो शेल अर्थेड है उसका अर्थ सिंबल लाभ दे. एंड इन्फिनिटी will be earthed, zero potential. Redraw करके series parallel. There's a basic formulas which you should know. Formula for cylindrical capacitor. Cylindrical capacitor यहाँ पे आपको this is one conducting wire. इसका रेडियस R1, इसका रेडियस R2. इसका कैपेसिटेंस कितना होगा? पाई एप्सिलॉन नॉट और 2 पाई एफ नॉट एल log of R2 by R1 between two wires, two parallel wires. Separation between their centers is D and the radius of them is A. इसका कैपेसिटेंस C इक्वल टू पाई एप्सिलॉन नॉट L यहाँ पे लिख देता हूँ. C इक्वल टू पाई एफ नॉट L log of D by 2A under root of there's a wire, long wire. There's also long cylindrical wires. There's a rod, conducting rod. There's a shell, cylindrical shell. अगर फॉर्मूला याद रहे तो then you can manage in exam. We can't derive in exam, and these are part of syllabus. These are all types of capacitor: parallel plate capacitor, spherical capacitor, cylindrical capacitor between two long wires also. Okay, fine. Next one we have the capacitors with the dielectric. There's a dielectric slab. The initial charge in the capacitor, let it be plus Q minus Q. The induced charge will be minus Qi plus Qi. So what is the expression for induced charge? Qi is equal to Q into 1 minus 1 by K. This is the expression for induced charge, and similarly the induced charge density also, the formula will be sigma equal to sigma into 1 minus 1 by K. This end will acquire negative charge, this end will acquire the positive charge. Then what is the capacitance of this? Will be K epsilon naught A by D, where K is called as a dielectric constant. Okay, let's do one thing. If there's a capacitor, यहाँ पे एक capacitor है, बाद में हम डायरेक्ट्रिक स्लैब इंट्रोड्यूस कर रहे हैं. Then what things will change and what will remain constant? This idea is very important. Earlier इसका charge Q था, Q naught, and capacitance कितना C naught. What is the C naught? C naught का value, it depends upon this one, distance D. So capacitance कितना C naught equal to epsilon naught A by D. जब हम dielectric slab introduce करेंगे, charge will remain same because this isolated capacitor. Then capacitance will increase. K epsilon naught A by D will become Kc naught. So the capacitance will increase by K times. Charge will remain same. No change in charge. Then what happens? The potential difference. So potential difference, like a earlier potential difference V naught equal to इसका potential difference V naught assume कर लेंगे, which is equal to Q naught by C naught. New potential difference, charge तो वही होगा, then capacitance is C. K C naught. So potential will become 1 by K. Then बाद में potential तो हुआ, इसका energy capacitance increase होगा, charge वही same, potential will decrease. Then what about the electric field? This is also very important. Earlier इसका electric field E naught, इसका electric field अब कितना होगा? E naught by K. इसका energy U naught equal to Q naught square by 2C naught. U equal to कितना होगा? Q naught square by 2C. U naught by K. So जब आप डायलेक्ट्रिक स्लैब इंट्रोड्यूस करेंगे, so what will happen to the electric field? Will decrease, potential will decrease, potential will decrease, capacitance will increase, charge will remain same. Similarly, जब capacitor is connected to cell, then dielectric slab is introduced. What conditions will come? Now इसका charge, initial charge Q naught, potential that will be E only, and इसका electric field let it be E naught. So initial values so we define करेंगे. Capacitance will be F naught A by D, and charge equal to C naught into E, and potential is E. Initial potential difference will be that of the cell. New potential difference will remain same. Capacitance will increase K times. Then the new charge Q minus Q. Q should be equal to C into potential difference K epsilon naught A by D into E. So charge will increase Q naught times. Then what happens to the electric field? The electric field E naught is V naught by D. The new electric field E will be V by D, and V remains same, so the electric field will not change. Though the medium changes, the electric field will not change. Charge will increase, capacitance will increase. Then what about energy? Energy is equal to C naught V naught square by 2, the initial energy. Final energy will be C V square by 2. Capacitance will increase, potential will not change. So energy will increase K times. So these are the general ideas what a student must have the base conditioner. Next we have the capacitance of a capacitor partially filled by a slab. Then what is the formula for this is given by F naught A D minus T 1 by K. There's a formula which you have to remember, very important. D minus T 1 by K. Then if it is filled up by multiple slabs, if there are multiple slabs are there, इसी कैपेसिटर को multiple slabs, this is one slab, K1 K2 K3, इसका thickness T1 T2 T3 and so on, area of cross section. Then इसका capacitance C equal to F naught A D minus T1 plus T2 plus T3 and so on, plus T1 by K1 T2 by K2 T3 by K3 and so on. When capacitor is filled up by with multiple slabs. If capacitor is filled up multiple slabs, this is formula for multiple slabs. So when capacitor is filled up by a conductor, some conductor, there's an iron, conductor means we'll take this as iron. What is the value of K? Will be infinity. Then capacitance is F naught A D minus T. When the same capacitor it is fully filled up by a conductor, then what will be the capacitance? Capacitance will become B minus D, will be infinity. Infinity means will be shorted. Okay, dielectric slabs, if it is partially filled, so there's a one basic idea. Then we'll take the capacitance, इसका equivalent capacitance. So the यहाँ पे जो the charge that will enter, a part of charge will flow here, a part of charge will flow here. So this will become parallel. Then this is equivalent to two capacitors. You can connect like this. One capacitor you can connect C1 C2 K1 K2. So effective capacitance between terminals X and Y, CXY, it will become C1 plus C2, will be K1 epsilon naught A by 2 by D, K2 epsilon naught A by 2 by D. then they are in series. The effective capacitance will be between X and Y, 1 by C1 plus 1 by C2, 1 by K1 epsilon naught A d by 2 d by 2. A series parallel one. Then if they are like this, next one more condition as going it. Already in videos I explained, so just in brief I'll revise it. So it's called d by 2, d by 2, a by 2 and a by 2. This will be, we have to break up this K1, K1, K2, K3, a by 2, a by 2, a by 2, a by 2, and the separation is b by 2. There's a, like this we have to calculate the effective capacitance. Now force on dielectric slab placed in capacitor which is connected to a cell. So this is a capacitor, this is a capacitor. It is connected to a cell. Now I'll place the dielectric slab. Let some x length of the slab, let it be there inside the capacitor. Then we have to calculate this particular force. So the formula for this is, you have to remember this, very important. The force by the capacitor on dielectric slab is given by epsilon naught epsilon naught L E square K minus 1 2D. What is E? E is the potential difference across the capacitor, this symbol. K is the dielectric constant, D is the separation, L is the area of, L is the side length of the dielectric slab. And this force is independent of X, which you have to remember. Okay, this. So there's a force on dielectric slab placed in capacitor which is connected to a cell. Now work done by an external agent to pull the slab from the isolated charge capacitor. Who is going to do work? Work done by external agent. Let me work done by external agent. Let me rewrite properly. To pull the slab from the isolated charge capacitor. So initial energy Ui, Uf, work done by external agent should be equal to mod of delta U. This should be equal to Uf minus Ui. Uf, so charge will remain same. Charge will not change. Only capacitance will change. So Q square by 2C minus Q square by, so इसका capacitance C naught, इसका capacitance C. What is C naught? F naught A by D. C is K epsilon naught A by D. C naught is only F naught A by D. So Q square by 2. So C naught का value F naught A by D. इसका वैल्यू k epsilon naught a by d. So q square by d 2 f naught a 1 minus 1 by k. So this much of work the X-ray should do to pull out the slab from the isolated charge capacitor. Okay, fine. So there is one more important formula which will be very useful for you in exams. Then force of interaction between the plates. The plate one will produce electric field E1. The plate 2 also will produce electric field. The charge which is present on the plate 2 will experience force due to charge present on the plate 1. So this force of attraction is what we'll call it as F1. So this F equal to how much? Q square by 2A epsilon naught. Similarly, there is a force of attraction between the plates. Then when dielectric slab is introduced, what will happen to this force? The charge will remain same. The electric field will remain same. So the force of attraction also will remain same. So this is F, this F. Q square by 2F naught. With interaction of slab, it will not change. Then if it is connected to cell, next condition, if it is connected to cell, then what ideas will come, we'll see it. Then if a slab is introduced, what will happen to this force of interaction? F dash. The new force of interaction F dash. This F dash will be K square Q square 2A epsilon naught. It will increase by K times, K square times. So the force of attraction between the plates will be F for isolated charge capacitor. When you introduce the slab, then remains same. When it is connected to the cell and introduced, then it will be condition. It will be easy for you. यहाँ पे दिखा देता हूँ. This is there. जब आप इंट्रोड्यूस करेंगे, then it will become k square times. This is very very important. Then some small application problems you have to remember. F is equal to like a अगर ये दो plates है, these are the charger plates. This one I'll connect it to the spring, and this one will be connected to the wall. I'll give charge plus Q minus Q. This is the spring. Then the force of attraction, electrostatic force, will be like this, Fe. The tension in the strings will be T, and the spring force Kx. So at equilibrium, what we can write, F equal to Kx. F is equal to how much? Q square by 2A epsilon naught Kx. So this will be the spring. Then it can also I'll bring another situation. There's a plate, another plate. Then charge Q plus Q. Who will balance this weight? Mg, tension. Yeah, there's a tension. There's a tension. Here the electrostatic attractive force, Fe. Here Fe, and this will be the tension. Then according to the concept, so it will be like this. F equal to T equal to mg. What is F equal to? Q square by 2a epsilon naught mg. We can calculate this mass, how much of mass we should suspend. So this electrostatic force acting between the plates, it can be countered by spring force, tension, it can be countered by the weight also. This is a spherical capacitor and this is a parallel plate capacitor. C2 is the capacitance C1. I'll give charge Q naught to this. What is the final charge on both the capacitors? So this has to be determined. So the charge on this will become Q1, here Q2 minus Q2. We have to get this charges. So this will become like a system C2, C1. One other plate will be at infinity, this will be at infinity. Now you can ask question like, sir, like, ये तो grounding यहाँ पे, okay fine sir, why from where this grounding? There'll be capacitance between this outer surface and infinity. Infinity potential will be zero, and zero potential means will indicate by the ground. So and what all the charge यहाँ पे हम इस तरह दे दे. So what all this charge will give will get divided using charge divider formula. Q1 potentials will be seen. Q1 by C1 equal to Q2 by C2. Q naught equal to Q1 plus Q2. Okay, this is like this. We can treat like a spherical capacitor. Connected with parallel plate capacitor. This idea. What is the dielectric breakdown? So inside the capacitor, we'll be having the dielectric slab. There's a potential. So what all we give the charge plus Q minus Q. Here charge will be induced minus Q. This will become plus Q. For any capacitor, there will be maximum potential the slab can withstand, or maximum electric field which the dielectric slab can withstand. So when we apply the, what is that electric field will be electric field E max. It depends upon the maximum potential by distance, by the separation between the plates. Okay, fine. And this E max will be a constant for a given capacitor, for a given dielectric region. Then similarly, what will happen to V max? V max will also be a, for a given capacitor will be constant. So any voltage across capacitor more than V max, the capacitor will burn out. That's called like a dielectric breakdown. Okay, there's a one small basics which we have covered it. You refer my video, some dielectric breakdown 3-4 problems I discussed. Okay, fine. So what are the capacitors? Like all ideas, I covered it. Everything you are supposed to revise all the formulas. Very, very, very important. So many formulas I explained. So those students who are preparing for only JEE mains, what is the essential first concepts? Read teacher, that will come by teacher notes. Next, revise formulas daily. Then you solve PYQ last 5 years. Those who are preparing for JEE Advanced, the same thing, like you have to and solve AITS of any institution which you have taken admission. PYQ is not needed. For JEE Advanced, no PYQ. So reading teacher notes is the most important. There only what when all your rank will depend on that one. Reading and thinking. So what should be again in teacher notes? What to do? You have to read think, understand, and remember. So if your teacher notes is having 3,000 problems, revise all those 3,000 problems. In our channel, I uploaded 3,500 problems. So read, watch them, think on them, understand them. Definitely you go to the advanced and you can see very, very, very benefit for you. Okay, kids, like a this what we have discussed. One shot. I think it's very lengthy. करीब करीब 2 घंटे मैं यहाँ पे रिवाइज कर चुका हूँ. तो प्लीज़ वॉच इट, लर्न इट. जो भी फॉर्मूलास है, अगर फॉर्मूलास तुमको याद नहीं रहे तो हर दिन आपको उसको पढ़ना पड़ता है, रट मारना पड़ता है. जब तक आपका फॉर्मूला स्ट्रांग नहीं होता है, it means you can't do anything. Even in advance also we need all these formulas. ओके बच्चों, लाइक ए कैपेसिटर वन शॉट, और इसको कॉन्सेप्चुअल शॉट बोल दीजिए, गन शॉट, वन शॉट को क्या तो नाम दे दीजिए, बट यू हैव टू वॉच, लर्न एंड सॉल्व पी वाई क्यू. जब तक आप तीनों ये नहीं करेंगे तो देयर नो पॉसिबिलिटी ऑफ गेटिंग गुड रैंक. प्लीज प्लीज पुट एफर्ट, पुट डू हार्ड वर्क. ओके फाइन. So there's a capacitor, so you can call it as one shot or gun shot or conceptual shot. Please watch, learn from it, and solve PYQ JEE mains. Then only open you'll get exact picture that the benefit of watching this one. Just merely watching again will not help you. जो भी यहाँ पे रिवाइज कर चुका हूँ, हर एक सोचना पड़ता है आपको और वो याद भी रखना पड़ता है. Then go to the formulas, revise them, then solve the PYQ. Then you can see the benefit in exam. Okay, Bacho, we'll come with the next coming chapter. One more on any one chapter, the one shot, like I'll upload it. Thank you for great support. Thank you. Good evening, kids. In today's class, we are going to discuss the resistor capacitor circuit one shot, or what you will call it as RC circuit. In that one shot, why I made this separately, sir? It's not a chapter; it's a subtopic. If you look at the JEE Advanced, we'll get 6 questions. Very, very important. Mains, okay, fine, 1 question. But JEE Advanced, interlinked, 6 questions. Not 1, 2. This will be the most important. So let me focus separately this one. For JEE means only 1 question. So here, first again, what is the methodology, how to utilize this one shot? Watch it. Then what all the important concepts, ideas I am explaining, you have to learn. Then after learning, then what happen? You can start rereading it. When you go through it 3, 4, 5 times, then you'll start remembering. Then solve PYQ. You can be in a more confident, your confident level will be at higher level, and you can see the benefit. This type of preparation, this is called like a hard work. You have to put effort. Fine. Now, how to what are the topics that are very important in this particular subtopic RC circuit? So resistor capacitor with a DC source one shot. Growth of charge in RC circuit. Then decay of charge in RC circuit, how the charge across capacitor increases and decreases. This is a thing. Then RC circuit with multiple loops, like we will be using KVL. Then RC circuit with multiple capacitor problems. Then RC circuit with initial charge in capacitors. These are the and next again one more RC circuit at t equal to 0 and t equal to infinity, steady state. These are the next set of problems. Very, very important for advance. You can't skip this topic. It's a subtopic, it's not a chapter. Fine. So we will start with the basic RC growth of charge in RC circuit. Okay, fine. Okay, we'll start with the growth of charge in RC circuit. Initially, capacitor is not charged. The switch is closed. The battery is switched on at t equals 0. Then we'll discuss the problem. At t equals 0, we have switched on. Then the current starts flowing. This current starts flowing. Let this variable current I. The current I will flow here. Current enters. It leaves this one. So the end where it enters positive, where it leaves negative. Current. Here the charge will get deposited, plus Q minus Q. From here current I, and this is I. This is the flow of current. We'll apply the KVL. E plus C minus IR minus Q0. If charge across capacitor increases, then the convention is dQ by dt. If the charge across capacitor decreases, then I equal to minus dQ by dt. When do we use it? Charge increases. This is a convention. So therefore, here we'll write down this one. We'll replace I as dQ by dt. This everything will become integral of dQ dt by RC. Then at t equals 0, the initial charge across 0. At any instant of time, let the charge. After solving this, I'll get CE 1 minus e to power of minus t by lambda, where lambda is called as a time constant. Directly I'm writing it, time constant of circuit. Why time constant? It will have unit that of the seconds. Then after getting this charge, we'll get the voltage, the equation for voltage across the drop across capacitor, the drop across resistor. This will be Q by C, which is equal to E into 1 minus e to power of minus t by lambda. The drop across resistor will be I into R. What is I? I is equal to dQ by dt. I'll differentiate this. I'll get the current. Here I'll write it here. I equal to dQ by dt. This will become CE lambda e to power of minus t lambda. Lambda is RC. ER e to power of minus t lambda. This is the expression for current. This is the expression for voltage. This is the expression for charge. You have to remember formulas, very, very important. If I plot this curve, the curve will be like this. Then expression for current, the expression for voltage across capacitor will be like this. And the current will be decreasing, exponentially will decrease. These are all this one. So what is the time constant? Time taken for the charge so this is the 1 lambda. Time taken for the charge to become 63% of final value. I don't have place. I'll write like this. 63% of time taken. What is how you define time constant? Time taken for charge across capacitor to become 63% of final value. What is the final value? Final value is CE. I'll move like this. Okay, agreed? Huh? So this is what we define the time constant. Then almost after 5 lambda, it will be almost a constant. This CE is called as a steady state charge. So what is the steady state charge here? Okay, there's a basic growth of current. Once it is fully charged, the switch is moved to the position 2. The same circuit will take it. No. Once the capacitor is fully charged, I'll move the switch from 1 to 2. Then here the capacitor will behave like a cell. It was having a charge, so it starts discharging. The discharging current will flow like this, plus minus. This will be the path. So the path, the discharging current will flow like this. There's a path it will take. There won't be current through the cell. Then we'll write down this one. So this will be applying the KVL, the loop equation, plus Q by C minus ID into R equal to 0. Q by C equal to ID into R. Q by C equal to minus dq by dt. So this will become dq by q equal to it will start decreasing. Say t equals 0, what was the charge? Q infinity. At any time t, let q be the charge. So then this will become log of q by q infinity minus t by RC, where RC lambda equal to RC time constant. So q equal to q infinity e to power of minus t by lambda. RC we are replacing by lambda. Log, if I send on the side, exponential. This if I differentiate, dq by dt, q infinity by lambda e to power of minus t lambda. Then negative sign will come. The discharging current, q infinity is what? CE, the steady state charge. Then this will be RC. So all the energy in the capacitor, finally when it becomes 0, all that will be taken by the resistor. So what is the heat generated across the resistor? That should be equal to Q infinity square by 2C. This is the heat generated in resistor. What all the energy in the capacitor, that will be taken by the resistor. So how the graph will be, roughly you can have the idea here only. The current through will decrease and finally will become 0. So this will be E by R. This will be T. This is discharging current. This is one again. You have come across formula. You have to remember this formula, very very important. And this is a heat generated. This is a time constant formula. Now at steady state, at t equals 0, how the capacitor? The capacitor will behave like a short circuit. There is one small important idea. Then initial current I naught will flow. What is I naught is equal to? I naught equal to E by R according to the equation what we had. Then at t equal to infinity, or you better call this as steady state. At steady state, where all capacitor there, put open circuit. No current will flow, so the drop across capacitor will be that of the applied EMF. This is the open circuit. Here this will be short circuit. Then what is VAB? VAB equal to E. This is very important. At t equals 0, the capacitor will behave like a short circuit. At t equal to, after a long time, will behave like an open circuit, and it contains energy. How much of energy in the capacitor will be? C E square by 2, or it should be Q infinity steady state charge by 2C. This is energy stored in the capacitor. We have this RC circuit with multiple loops. There's a cell, resistor 3R, 2R, and there's a capacitance C. Initially, capacitor is not charged. Okay, now we have to calculate the charge across the capacitor at any time and current in all the branches. So, what are the many methods are there? We'll assume the current here. Let it be current here, I1. The main branch current, let it be I. Here, I minus I1. And there's a variable current, I minus I1. Okay, you can write the loop equation where current enters positive, where it leaves negative. Like this, you give polarity. Let any instant of time charge across capacitor be Q. Write KVL. Then afterwards, writing KVL. This will be plus C. I'm using this path E minus IR minus I1 to R minus Q by C 0. Then minus I1 to R minus Q by C plus 3R I minus I1. Then one more loop equation, plus C minus IR 3I minus I1. Solving this, we'll get the required answer. And what is I1? I1 equal to dq by dt plus dq by dt. Why plus? Charge across capacitor is increasing. This is one method. Or other easiest method, we can directly get the steady state charge at t equal to infinity. At t equal to infinity, what is the capacitor? Capacitor will behave like an open circuit called AB. We'll calculate, and the total current, the current will flow only here. We'll calculate the VAB. So what is first? I is equal to, this I is equal to how much? I equal to E by 4R. Then we'll calculate VAB. VA minus 0 into 2R minus I into 3R minus VB 0. VAB equal to 3R into I. 3R. I is how much? E by 4R. Then what is the charge? The steady state charge is equal to C into VAB. 3CE by 4. Then we know charge and how to get the time constant. Then this is about the steady state charge. To calculate the time constant, what we should do, where all the cell is there, replace with its, make EMF of 0 and replace cell with internal resistance. There is no internal resistance, so this everything will become like this. Two R, 3R, and this is R. So the effective resistance as seen by this. So this will be 3R, 3 by 4R, RAB, 2R into 2R plus 3R by 4. As seen by the, you stand here, and what is the effective resistance as seen by the terminals AB. These two are in parallel. That effective will be in series with this one. So this will be 11R by 4. Then what is the time constant? The time constant will be C into RAB, 11RC by 4. Then you can write expression for charge. No, charge equal to Q infinity 1 minus e to power of minus t lambda. After substituting this, I'll get the charge in capacitor at any time t. This will be 3CE by 4, 1 minus e to power of lambda. This will be 4t by 11 RC. This is the expression for, differentiate this, we'll get the current I1. So what is the expression for I1? I1 will be 3CE by 4 11 RC e to power of minus 4t by 11 RC. Then expression for current will be T by lambda. Lambda is how much? Lambda is 11 RC by 4, no? This will be 4 into 11 RC. This expression for current will be I1 equal to, C will get cancelled out. 12 E by 11 R e to power of minus. This is the expression for the current I1. Once you know I1, substitute I1 here, we'll get I. Then we'll get current in all other branches. There's a multiple loops will come. Either you can use this calculus method or use this particular method. I have circuit like this, so we have to calculate the charge across capacitor at any time t. Again, the same method. Let me go for I. Here I1, here I2, here I. Then give polarity. Then write down the loop equation. Let any instant of charge, let it be charge across capacitor be Qi minus Q. Then the equation will be plus C minus I to 2R, I into 3R, I into R equal to 0. Then writing equation here, Q by C plus, this is a positive plate. Let me, then I'll move like this, plus Q by C minus I2 into 2R equals 0. Who is responsible for the current? I equal to plus dq by dt. Then what is the KVL equation equal to? I equal to I1 plus I2. Substitute this and you can solve it. I1 is responsible for dq by dt. So we'll write one more loop equation. Plus C minus Q by C minus I into 4R equal to 0. What is I? I is equal to I1 plus I2. Okay, agreed. This I we should replace. I should be equal to I1 plus I2. What is I1? I1 is dq by dt. What about I2? I2 is this much. Then solve, we'll get the differential equation. By integrating, we'll get expression for charge across capacitor at any time t. Or at steady state, at t equal to infinity. I'll write this I1 here. Another method, at steady state, how the capacitor will be open circuit. We'll calculate the drop here. A constant current I will flow. What is I equal to E by 6R. Then what is the drop? VAB is equal to VAB equal to I into 2R. E by 3. Then the charge Q infinity equal to C into VAB. C by 3. Then what is the time constant? How to find out the time constant of circuit? Time constant of circuit you have to find out in this way. All these things I'll write it here. I is equal to I1 plus I2. Applying KCL at this point. Now come for how to calculate the time constant of circuit. Where all cell is there, replace with a short circuit. Then it will be like this. This will be R, 3R, 2R. The cell EMF we have made 0. Then effective resistance will be 4R parallel to 2R. 4R parallel to 2R. 4 2 ja 8, 8 by 6, 4R by 3. Then time constant of circuit will be RAB into C, 4RC by 3. Then what is the expression for charge? Charge equal to Q infinity 1 minus e to power of minus t by lambda. Then differentiating this, we'll get the current I1. You have two approaches. This one approach. This approach is, if you're not good in calculus, if you know calculus, use this one. If you know the differentiation integration, use this one. Or this is by steady state approach. So where all cell is there, you have to replace with a short circuit or replace with internal resistance. There is no internal resistance of the shell, 0, therefore we are replacing with a short circuit. So where all cell is there, that you have to replace with a short circuit. Okay, multiple loops, this is a basic idea. We have the multiple capacitors. Here the current I1 will flow, current I2. Here the main branch current I will flow. This I will break up here, I1, and this is I2. Again it will combine. What is the expression for I1? I1 equal to E by R1 e to power of minus T R1 C1. Separately, the current in this will depend on these two resistor capacitors. The current here will depend upon ER2 e to power of minus TR2 C2. Next we have there's a capacitor with initial charge where condition given Q0 less than C. At an instant of time, let the charge across capacitor, let it be Q minus Q, and let the current be I. Then writing KVL, E minus Q by C minus IR equals 0, where I equal to dQ by dt. Then this solving will end up equation of like this, dt by RC. At t equals 0, what is the charge in capacitor? It is Q0, no? Substitute that charge. At an instant of time, let it be t. If there's some initial charges present, then this equation will become log of CE minus Q by CE minus Q0 is equal to minus T by RC. This will become CE minus Q okay, fine. So this is the expression for charge initial. If initial charge is present, this is a basic method you have to apply it. Put equals 0, then what is the charge? Charge will be Q0. After a long time, what will be the charge? Will become equal to CE only. What is the steady state charge? This is a steady state charge. This is a RC circuit with initial. Next, one more condition. I have the capacitor, the plates of capacitor given charges Q1 and Q2, and switch is closed. We have to calculate the charge in the capacitor at any time t. So when you close this switch, after some time, the charge will be, how much of charge will be there? The initial at t equals 0 will discuss first. This will become Q1 plus Q2 by 2. Q1 minus Q2 by 2 minus of Q1 inside minus Q1 Q2 by 2, and again outside Q1 Q2 2. These are the charges. When you close this switch, the charge will be this. So this charge will not get disturbed. Only this charge will change. So this charge will remain as it is. This charge will not change. only the charge inside the capacitor is going to decrease. So this will become Q is equal to initial charge how much, Q1 minus Q2 e to power of minus T by RC. This is a discharging. So when the plates of capacitor are given different charges, there is a basic method. RC circuit with multiple capacitors. RC circuit with multiple capacitors. There is a battery. There is having a charge, initial charge Q0. There is uncharged. There is a charged capacitor. I'll close the switch. We have to calculate the current through this circuit at any time t. Once we get the current, we'll get the charge here. So after closing switch, the whole circuit will be no. I'll close the switch. This Q0 charge is there. This will become Q0 plus Q, and here charge Q minus Q, and the current, let it flow like this. The current will take path here. The current will take path. So then we'll see that one. How the capacitor will behave like a cell at that instant. If it is uncharged, it will behave like a short circuit. We'll calculate at t equals 0, we'll calculate the current. At t equals 0, where all capacitor is there. Charged capacitor you should replace with a cell. Then the uncharged capacitor you have to replace with a short circuit. This is a very important concept. Hope you are getting now, sir. What is this battery? This applied EMF. This is due to capacitance. The 2C capacitor will behave like a cell. Then how much of EMF of this will be? Q0 by 2C. There is a resistor, there is a capacitor short circuit. Then the current initially I0 will flow here. We'll assume that Q0 less than C. So the current will initially flow like this. Then this will become plus E minus Q0 by 2C minus I0 R equals 0. So I0 is equal to, no, I0 will be E minus Q0 or 2C E minus Q0 by R. Then at any time t, so we'll write down the equation. At any time t, this will be plus C minus Q0 plus Q by 2C minus IR minus Q by C equals 0. Differentiating this, dE by dt. Q0 is a constant, so this will become 1 by 2C dQ by dt minus di by dt minus this will become dQ by dt into 1 by C equal to 0. This will be constant. Then this will become I by 2C. This will become 1 by R di by dt minus I by C equals 0. Now further we'll solve it. This will become I'll put bound here, it will be easy for you. Now further simplification will be 3I by C equal to di by R dt. R, capital R will be here. Or di by I is equal to dt by negative sign, let it be here. At t equals 0, what is the current? I0. At any instant of time, let it be I. This is a method, so this will become log of I by I0 equal to minus 3t by RC. This is the expression for current. Then I equal dQ by dt, then we'll get the charge. So one charge capacitor, another charge capacitor is there. So we have to use this method. So now what is this? Cell, and there's a short circuit. Uncharged capacitor, short circuit, charged capacitor through a cell. There's a one multiple thing come, there's a method you have to apply it. Fine. Now we have to calculate the steady state charge across this capacitor at t equal to infinity. We'll draw the circuit. After long time, what will be the capacitor? Capacitor we have to replace with the open circuit. Already you know the method. So where all capacitor there, I'll replace with an open circuit. Where there's open circuit, no current, so the current will flow only here. The path it will take is current I, this is I, this is I. The current will only take path like this. Then polarity you give it plus minus, I equal to 10 minus 5, 2 plus 3, 1 ampere. Then VAB minus 10 plus 3I minus 4 into 0 minus VB equal to 0. VB equal to 10 into 3I. VAB equal to 7 volt. This is a method where all capacitor replace with open circuit and find out the steady state charge. Okay, kids, this is about the discussion. It's a very short, very small topic and very important for JEE Advanced. That's why I just give all the brief ideas. So please go through it, all the different conditions which are there. Work out different types of problems. Really, you can improve a lot using this basic methods. Almost all ideas I covered it. For JEE Main, this is more than enough. For JEE Main, this is more than enough. Okay, fine. I'll update like a coming. I'll update few more topics. There are a lot of second year topics left over. I'll update one shot of that also. That one. So prepare well for JEE Mains as well as those who are preparing for JEE Mains. So have the concept clarity, formulas, PYQ. Those who are preparing for JEE Advanced, concept clarity, formulas, and you should explore more number of numericals. This is one basic methodology. Okay, thank you everyone. So I'll end up the session.